Okay, so as we continue to prep for our final exam, we're going to talk about proving identities. So what we want to do is show that this is an identity by either making the left-hand side equal to the right-hand side or the right-hand side equal to the left-hand side. And in general, what we will do is sort of work with the one that looks a little bit more complicated. So I'm going to work with this one. So I see on the numerator I have sine 2 theta. Well, that's a double angle. So I'm going to use the double angle identity, which says that sine 2 theta equals 2 sine theta cosine theta. And in the bottom here, my writing's a little sloppy, but this is 1 minus sine squared theta. So this deals with the Pythagorean identity. That's going to give me a cosine square theta in the bottom here. And after that, let me see. We're going to go ahead and cancel some things. This cosine will cancel with one of these cosines, leaving us with, let's see, 2 sine theta over cosine theta. And that equals 2 times tangent theta, because tangent theta is sine divided by cosine. So that's an identity as well. So there we go. We just proved this trigonometric identity. So after that, you can stop. So here's an interesting one. This one is also going to use something different. It's going to use angle addition, or in this case, angle subtraction formulas. So I'm going to go ahead and try to make this more complicated looking side look like the right-hand side. So I'm going to start with the correct color. So cosine of x minus y becomes cosine x cosine y plus sine x sine y. And let's see, I'm going to write this underneath each one of these. I'm going to decompose this fraction. So cosine x cosine y. And here's why I did that, because I can see this cancels with this. So that's going to leave me with a 1. And then I have my plus sign, right? And then I have, let me see, sine of x over cosine x. That's tangent x. And then I have sine y over cosine y. That's tangent y. And that equals what I wanted to have it equal in the beginning. 1 plus tan x tan y. So this and this are now equal. We showed that they are the same. So this one is going to use a little bit different technique. It's almost like when we used to try to get rid of the like complex numbers in the denominator. So we're going to use like what kind of looks like a conjugate, though it's not. And I want to show that it's equal to this side. So let's go ahead and start by writing my left-hand side down. So what I want to do is, and I'll switch colors here, multiply the bottom by 1 minus sine theta. And if I multiply the bottom by that, I have to multiply the top by that. So what's going to happen here is, like I said, similar to with our conjugates, when we FOIL this, the bottom, first times first is 1. My outers are negative sine theta. My inners are positive sine theta, so those will add off. And last times last, positive sine theta times negative sine theta gives us negative sine theta. So I'm going to distribute in the top cosine theta times 1 is cosine theta minus cosine theta times sine theta. I don't know why, but I'm writing cosine first. Doesn't really matter. And then in the bottom, first times first, that was 1. We know the outers and inners add off, and then last times last is minus sine squared theta. So I like that because that's Pythagorean identity. So that denominator I'm seeing right away goes to cosine squared theta. And in the numerator, I'd have, let's see, still have the cosine theta minus sine theta, cosine theta. So I'm going to do what I did in the previous one. Let's go ahead and decompose this. So cosine theta over cosine squared theta minus sine theta, cosine theta, over cosine squared theta. And the reason I'm doing this, when you see that you're going to go toward two terms here, so term minus a term, so I saw that I could make this into a term minus a term, so that's why I did that, in case you're wondering. So cosine theta cancels with one of these, so that just becomes 1 over cosine theta. And let me see. This cosine cancels with one of these, so that becomes minus sine theta over cosine theta. And let me make that minus sine white. So let me see. This is secant theta. So I'm going to write that here. Then minus sine theta divided by cosine theta is tangent theta. So looking back up here, looks like we did make this. Yes, those are the same. So that's how you tackle these. Now, sometimes you will tackle them and you'll do a whole bunch of work, like this, and you'll realize that you're not getting towards what you want to get to, and that's okay. Sometimes you just need to start over again, or sometimes you need to start simplifying both sides. You can simplify both sides to equal something else. So anyway, I hope you enjoyed that. Please go ahead and give it a like hit the like button, please. And I will catch you in the next examples.